Okay, so in this video we're going to look at finding the present value of a series of cash flows which consists of an annuity for a few years and an additional amount at the end. So let's take a look. So in this case we have an annuity which consists of $100 per year for 3 years, and then we have an additional $500 at the end of the third year. And it asks us what is the present value of this $100 per year for 3 years with additional $500 at the end of year 3 if the interest rate is 8% per year. So what we can do is do a timeline. So we have 3 years, and what we have is $100 per year with an additional $500 at the end of year 3, and the interest rate is 8% per year. And the question is, what is our present value? So to solve this, what we can do is we can start off by finding the present value of each cash flow. So to find present value is equal to future value divided by 1 plus I to the appropriate number of periods, assuming we're using a periodic rate here. So for this first cash flow, the present value is going to be equal to $100 divided by 1 plus the rate per year, which is going to be 0.08 raised to the 1 because you need to bring it back 1 period. So I'll pause for a moment so you can work out that math. Okay, so if you paused it to work that out, what you should have gotten is a present value of $92.59. Okay, so now what we need to do is we need to find the present value of this second cash flow. So for that, present value is going to be $100 over 1 plus 0.08 raised to the 2 because we need to bring it back 2 periods. So I'll pause for a moment to allow you to work that out. Okay, so if you worked that out, what you should have gotten is a value which worked out to $85.73. So now what we have to look at is this third year. So if I have $100 in year 3 and $500 in year 3, because they're both in year 3, I can add those up, and I'd have $600 in year 3. So to find the present value of that, what we can do is do that in one calculation. So we would have $600 over 1 plus 0.08 raised to, because I have 3 periods here, the third power. Okay, so in that case, I'm going to pause that and let you try that out for a moment. Okay, so if you paused that and tried it out, what you should have gotten is $476.30. So to find the overall present value, what we would need to do is add all these up. So I recommend you pause the video and add them up and see what you get. Okay, so if you added them all up, what you should have gotten is $654.62. So that would be the present value of the $100 per year for 3 years with the additional $500 at the end of year 3 when the interest rate is 8% per year. So that would be our answer. Now, as you might suspect by now, if you've been watching all these different videos, we can also do this with our time value of money solver. So if we go to the time value money solver, then you have these options. So let's go through these. As always, NI and payment have to connect to the same period of time. So in this case, everything's annual because we're getting $100 per year and the interest rate is 8% per year, so everything's annual. So N needs to be the number of years, which is 3. And I needs to be the interest rate per year, which is 8, because it's looking for it in percentage format. Present value is what we're trying to find. Payment will be the $100, because the payment line in your calculator is for an annuity, and we have $100 every period for the specified number of periods, and that constitutes an annuity. So this payment is the annuity part. But then I have this $500 out here that's in addition to the payments. Well, that $500 is at the end of the time period, so I could call that a future value. So I'll put that here in the future value line. And in that case, notice that all the cash flows that are coming in the $100 payments per year, and the future value, they both have positive numbers here to denote that they are both cash flows that are coming in. Now also note that this is $100 per year, and we're assuming in this case, based on the fact it doesn't say anything different, that we're dealing with an ordinary annuity. So the type is going to be end. Okay, so I'll pause for a moment, and I recommend that you take a moment to pause the video and work this out and see what you get. Okay, so if you pause the video and work that out with your calculator, then what you got was negative $654.63. Now this is slightly different than what we got over here, and the reason that's slightly different than what we got over here is because for each of these numbers we rounded it off just a touch, and therefore we got just a tiny bit of a different number. And also note that this is a negative sign here, which we'd have to interpret with a grain of salt. But basically we got the same answer, which is $654.63. Now, as you can probably suspect, if you've been watching these videos, then we could also find this present value using Excel. So the way we would do that is we would do equals present value, or PV, open parentheses, and now it looks for the rate, which is going to be 8%. So 8%, and then it looks for the number of periods, which is 3. Then it wants the payment, which is the annuity component, so that's going to be $100. Then it looks for the future value, if we have one, and then we do have a future value that's not part of this payment stream, so that future value is going to be $500. And if we wanted to, we could also specify the type of annuity, but in this case we have an ordinary annuity. So if we leave it blank, Excel will actually assume that it's an ordinary annuity, and since it is an ordinary annuity, that's fine. So we can close our parentheses and let Excel do its magic, and if we do, we'll get our answer. I recommend at this point that you pause the video and try this out in Excel and see how you do. Okay, so if you pause the video and tried it out, what you got was negative $654.63, which lo and behold matches exactly with what our calculator gave us and was really close to what we got when we did each of the calculations by hand. Notice that, again, Excel gave us a negative sign, kind of like the calculator did. So if you actually want a positive value in your cell in Excel for some reason, you would need to stick a negative sign here between the equal sign and the present value, and then that would give you a positive value. I recommend that you try this out with a few other numbers and a few other kinds of problems. See how you do.